So chapter 3 introduces the idea of a function along with all the different wonderful things we can do as we work with functions. We will deal with functions for the rest of the course. So pretty much every relation we have from here on out is going to be a function. So this is section 3.1, part 1 on functions. I wrote all the definitions on the board. So we're going to start off with what we already know. A relation is just a correspondence between two sets. We're used to all of the equations that we've dealt with in the previous chapters being a type of relation. What we're going to do is take those equations and classify them as either a function or not. So literally what we're doing is we're taking all of those relations, and again, I need you to think of that in terms of equations, and they're either going to be a function or not. And that's what we're working on in this first section. So the definition of a function according to your textbook is it's a relation, so it's an equation, that associates each element in the first set exactly one element in the second set. So the way I like to think about this is one input gives one output. And that's the way I like to think about it. It's a layman's definition of a function. Each input corresponds to exactly one and only one output. Okay, the domain happens to be that first set that you're starting off with in. That's the set of input values. For us, it's the set of X values. The range is that second set, the set of output values. For us, it's the set of Y values. So our first set is always the domain. The second set is the range. And the way to remember that is they're luckily in alphabetical order. So that helps us too. The independent variable is a terminology that your textbook uses also. The independent variable is the input variable, which is X. The dependent variable, this is the one that depends on what you use as an input, is the output variable, or Y. So Y depends on X is how we make that statement. So the first thing we need to work on is identifying whether or not a relation is a function. And to do that, we do mapping pictures. And so there are 3 of them on the handout. Let's take a look at those 3 pictures. So example 1 simply wants us to determine which of the following relations is a function. So A, and what you see is, you see the first set, which is the domain. You're also going to see that second set, which is the range. Again, this would be our set of X values. This would be our set of Y values. Specifically, we have -1, 0, 1, 2, and 3. And then over here we have 3, 5, 11, and 21. And then what you see are some arrows. Now the arrows is actually how we travel from the first set. It's the correspondence to the second set. It's what we do to the number to get that output value. So what you see is you see -1 corresponding to 5. You see 0 corresponding to 3. 1 corresponds to 5. Whoops. 2 corresponds to 11, and 3 corresponds to 21. And what you ask yourself is, does each input correspond or relate to only one output? And the answer is yes. And that's what makes this a function. -1 corresponds to 1 output. 0 corresponds to 1 output. 1 corresponds to 1 output. It's okay if they correspond to the same output. They can only correspond to a single output. 2 corresponds to 11, and 3 corresponds to 21. So this first one is definitely a function. Let's switch to blue because my marker's. Okay, what about the second one? Sorry, me opening the marker. Okay, part B on that one shows, again, a domain. I'm going to use a capital D, and I'll use a capital R for range. This time we have some letters, and that's okay. There are lots of relations that we can't write as functions. And we've got Roman numerals sitting on this side. So A corresponds to 3. We also see that A corresponds to 1. And I really don't have to go any further with the drawing because that right there tells me this relation is not a function. I have one input and it is corresponding to 2 different outputs. So it is not a function, so no. And that's because A corresponds or relates to 2 different outputs. So it's definitely not a function. Okay, what about the third one? Right, I found that paper towel actually works as the best eraser on a whiteboard. Part C, the picture here goes back to numbers. This time we have X and Y, but again, this is our domain, this is our range. We have 3, 0, -3, -6, and then we also have a -1, 0, and 2. The 3 corresponds to the -1, 0 corresponds to 0, -3 also corresponds to 0, and -6 corresponds to 2. So you're asking yourself the same question, does each input correspond or relate to a single output? And the answer is yes. 3 only has a single output, 0 has a single output, -3 has a single output. Again, it's okay if 2 different inputs go to the same output. That's not what our relation as a function says, and it's okay. And -6 corresponds to 2. So this one is yes, a function. Hopefully that stops. Those are mappings, of what those are called, and they're a great way to start the idea of a function. Okay, but what if instead of a mapping, we have an equation? So example 2 gives us 2 equations and kind of asks the same question, right? It basically says determine whether the equation defines y as a function of x. And the very first one says y is equal to 2x minus 5. So to answer this question on whether or not this relation, this equation is a function, you have to ask yourself 2 questions. So the first question, first of all, is can you isolate y? So can I get y all by itself? Well, in this equation, it's already by itself. So that answer would be yes. So this is a yes. Then the second question is if you can isolate that, if that's true, does each input give one output? And that's the second question. And again, you can see that that's definitely what a function is all about. So you simply ask yourself, well, if I put in a value for x, how many y's am I going to get out of it? Well, no matter what number you plug in, 3, -2, 1/3, 0.7, 1 million, each input is only going to give one output. So this is definitely a function. So because the answer to this question is also yes, this is a function. And you should recognize that is a line. So we know that the slope is +2 and the y-intercept is -5. So we recognize the equation. Part B, you may not recognize. We have x squared plus y squared is equal to 3. Wait a minute, you should recognize that. If x and y are both squared, isn't that a circle that's centered at the origin, right? X squared, y squared, that's x minus h squared plus y minus k squared is equal to r squared. So it's got a goofy radius square root of 3, but we do recognize the equation, which is nice. This time, same 2 questions, but we have to do some manipulation. So the first thing we're going to do is come in and isolate y. We need to get the y by itself. Let's see if it's possible. So we'll move the x over. That would be 3 minus x squared. And then we're square rooting it both sides. So y is equal to plus or minus because we're solving and we're taking a square root. So we definitely can isolate it. So that's a yes. However, what about that second question? If I come in and put an answer in this time, so let's put in 2. I'm sorry. Let's not put in 2. Let's put in 1. So if I put in 1, I get 3 minus 1 squared. 1 squared is 1. 3 minus 1 is 2. This would give me the square root of 2. So if we input a 1, then y is going to equal plus or minus the square root of 2. And I agree the square root of 2 is not a nice answer, but the key here is that we get 2 answers. 2 outputs. So because each input is giving us 2 outputs, it's a no, so this is not a function. So when would we not be able to do the isolation on the y? Well, you can't isolate y if you have something like y squared plus 2y minus 1 is equal to x. Because y appears as 2 different terms in 2 different degrees. One's a square and one's a first degree. You can't isolate the y there. So that one's also not a function. So most of the time in our class, we're going to be able to isolate it. It's really that, does one input give one output? That's the question.